Mahibulawat and she is my project partner, Harshita Rana. We are from Alok Senior Secondary School, Fatehpura. We are studying class 9. Today we are here to present our presentation on quantum entanglement. So basically, what is quantum entanglement? Quantum entanglement is a phenomenon where two or more particles become intrinsically linked. The state of one particles instantly influence to the other particles, regardless the distance separating them. Then, why is quantum physics so hard to grasp? Those who are not shocked when they first come across the quantum theory cannot possibly have understood its lens for. I think I can safely say that nobody understands quantum mechanism. This isn't a lecture, it's a journey to replace simple model with a deeper truth. An inquisitive mind's journey begins. I am an electrical engineer with lifelong interest in the theoretical physics and come up with my own basis analogy for quantum entanglement as a mental model. This helped me to demystify the concepts, but I would like to know how accurate it is from Thomas experts. A first attempt to tempt this spooky setup, two coins, two separated boxes. The rule inside the box, the coins set up from opposite state, head or tail. The state is hidden but the predetermined. The result. Open one boxes and sees head. You instantly know the other is tail. The conclusion. This feels like simple not faster than the communication. The magic is gone. But what's happened when the question is changed? Imagine a coin. A normal coin has fixed sides, head or tail. Now, no matter how you look at it, it is still head or tail. Now, imagine a quantum coin, spin particles. It does not have fixed direction. It only decides when you measure it. You must choose direction to measure. A better analogy: gloves and shoe. Imagine two closed boxes. Alice opened one, Bob opened the other boxes. Inside each box is either a shoe or a gloves. But the box doesn't decide what is it until you open it. The property you find gloves or shoe depends on the question, what question you asked, what door you open. The last step of classical intuition. One may say just because I wasn't able to measure a observation, it doesn't mean it didn't still have a value. No, all observations really do have some value from the very beginning. It's just like a coin, either a head or tail, the whole time. The experiment that proved reality is weird. The theory. In the 1960s, the John Stewart Bell's comes with a mathematical theory could that distinguish between the quantum mechanism and any local hidden variable theory. The experiment is starting in the 1970s. Experiment by physicists like John Clauser measured thousands of the entangled pair that randomly chosen it. The verdict. The results consistently violate Bell's theorem. The observed correlation are stronger than any classical model with pre-existing information can possibly. Local hidden variables are ruled out. The spookiness is real. The breakthrough, contextuality. The properties of particles are not fixed. This applies even across vast distance. Unperformed experiment and no result. From weirdness to power, the qubit. First is bit. First is bit. Think a light switch. A bit can be only one at the time, either on or off. Second is qubit. It can on and it can off, and it can be between on and off at the same time. Entanglement, a network of possibility. When the hundred of particles entanglement you, they still act as a unified object.
The quantum toolkit, computation, communication, or cryptography. Quantum computation, solving problem intractable for any classical computer. Dynamics coding, sending twice the information with any particles. Quantum computing, quantum cryptography, creating unhackable communication, the act of spying destroy the message. The grand challenge, decoherence. Decoherence is the one of the most major roadblock of the quantum computation. The quantum computation process occurs in a term of the parallel evolution of entangled qubit. The nature of visual distribution of quantum notion has the potential to bridge the gap between abstract idea and intuitive understanding. Thank you.
Thank you and have a wonderful day. नाइस प्रेजेंटेशन। एक बच्चियों के उत्साहवर्धन के लिए जोरदार तालियों की गड़गड़ाहट होनी चाहिए। नेक्स्ट परफॉर्म के लिए मैं कोड नंबर 213 को इनवाइट करती हूँ।
Good afternoon, judges. My name is Ashish Manaria and they are my partner project, Rajit, Surivir and Ashish from Alok School, class 9. So, today we are discussing about the topic photoelectric effect. So, what is photoelectric effect? The photoelectric effect occurs when light strikes a metal surface and causes electrons to be emitted. This fundamental phenomenon demonstrates the particle-like nature of light. It is discovered by Heinrich Hertz in 1887 and its full explanation is come by Albert Einstein in 1905, earning him the Nobel Prize. This effect provided crucial evidence that light is composed of discrete packets of energy called photons rather than solidly behaving as a wave. The quantum nature of light. Photon energy. Light is composed of photons, each carrying energy given by the equation E equals to h, where E is the power of photon and h is Planck's constant. Properties of photons. Photons are massless and carry no electrical charge. However, they possess a specific amount of energy that can be transferred to electrons. So, their energy must exceed a threshold energy, known as work function, specific to each metal to liberate an electron. Below this threshold, no electrons are emitted regardless of the light's brightness. Photons interfacing with a metal surface. This illustration visually represents the photoelectric effect when individually photons transfer their energy to electrons within the metal causing them to break free. Part 2. Experimental setup and key observations. The classic photoelectric experiment uses a vacuum tube with two metal plates, a cathode and an anode. When light illuminates the cathode, emitted electrons flow to the anode, creating a measurable current. Finding key findings. Threshold frequency. No electrons are emitted if the light frequency is below a certain threshold, irrespective of its intensity. Kinetic energy versus frequency. The kinetic energy of the emitted electrons depends on only the light's frequency, not its intensity. Intense emission. Electron emission is immediate with no observable time delay after the light strikes the metal. Einstein photoelectric equation. The core equation is equals to F. Understanding the terms. H is the smallest unit of energy. F indicates the frequency of incident light. And Ke max indicates maximum energy of the emitted electrons. This, this graph illustrates a key observation. Kinetic energy of emitted electrons increases linearly with the frequency of light, but only after a certain threshold. Frequency is denied below threshold. No electrons are ejected.
Photoelectric in quantum technology. Solar energy, the core principle behind solar panels, converting sunlight directly into electricity by releasing electrons. Light sensor, essential for digital cameras, light meters, and automatic lighting systems, detecting and responding to light intensity. Quantum foundation help in experimentally determining pranks constant and forms a basis for advanced quantum devices, including quantum computing and communication systems. Constellation why the photoelectric effect matters. Parad- Paradigm shift. It fundamentally altered our understanding of light and energy transmitting from a purely wave-based model get away to quantum. This effect is curious stepping stone into the rhythm of quantum physics and laid to groundwork for countless modern technologies. Transformative impact. The photoelectric effect remains a shining example of how foundational scientific discoveries can profoundly transform the world around us. Thank you for listening. Question.
तालियों की कंजूसी की जा रही है। इस कार्यक्रम को अच्छा बनाने के लिए तालियां बजनी चाहिए। मैं नेक्स्ट प्रस्तुति के लिए इनवाइट करती हूँ कोड नंबर 214।
Good morning everyone. My name is Preraj Kasha and today I am going to present this PPT. What is quantum mechanics? Quantum mechanics is basically a fundamental theory that describes matter and energy in atomic and subatomic levels. The impossible glow, black body radiation. The classical physics fail to explain that why the hot objects do not why the hot objects don't emit infinite energy. Energy isn't smooth, it's chunky. And Max Planck in around the early 20th century discovered that energy isn't smooth, it's chunky like staircase. The collaborative investigation. The quantum revolution was not a solo job. It was a teamwork of teams of detectives like Niels Bohr, Albert Einstein, and Max Born. The primary hubs at the time of discoveries were Göttingen in Germany and Copenhagen and Munich. Duality and uncertainty. We know that light can be both wave and a particle. The wave and the particle, the, the double slit experiment. In this experiment, it is concluded that when the both slits are open it creates an interference pattern, and it creates an interference pattern. The new theory of crime. The scientists discovered two matrix mechanism and wave mechanism. The theory on trial. The theory was put on to experiment to test and experiment. The case study one, Paul's exclusion principle. Wolfgang Pauli discovered Wolfgang Pauli proposed an ad hoc rule that no electron could be occupied in the same quantum. The case study two. In 1926, when the Schrödinger equations to molecules, Friedrich heard that discovered that particles wavefront could extend into a classical Fordin region.
The verdict. The jury concluded that the universe is built on three rules. First, quantization. Second, dual nature. Third, luck, also known as probability. The legacy. This weird discovering lead to the invention of MRI machines, transistors, and chips used in our phones. Communication of the world's simple summary. Because quantum physics is so confusing, scientists use images and text to explain it easily. Why the story still matters? The story is not over. These are now used to build quantum computers that could solve problems in seconds that take us years today. Thank you.
तालियां नहीं सुनाई दे रही है मुझे, एनर्जी डाउन हो गई है ऐसा लग रहा है मुझे। मैं इनवाइट करती हूँ 215।
You will turn on a light and the electrons start flowing without touching any wire. Do you think it's a magic? No, it's not a magic. It's a scientific phenomenon called the photoelectric effect. Good morning, esteemed judges and my dear friends. Today I am here to showcase my PPT on the photoelectric effect that well explains through the concept of quantum mechanics. Now, what is photoelectric effect? Photoelectric effect is the concept. Photoelectric effect is the quantum mechanical concept in which the light energy is converted to emitted electrons from the metal plates. Metal plates are taken from the two types, cathode anode plates and other types. Firstly, the light falls on the cathode plates and the electrons on the cathode plates start flowing through it without touching anything to the second plate, and that is particularly the photoelectric effect. Photoelectric effect has certain laws. First of all, when the light is coming through the threshold frequency, that is more than the number of electrons, then the energy is converted into kinetic energy, but the other things are converted into electrons. But if both of them are equal, no kinetic energy, and the electrons will start moving from cathode plate to the anode plate. Thirdly, we have if the both number are equal, then there will be no energy and the electrons will be emitted. But if the threshold frequency is less than the number of electrons, then no kinetic energy and some of the electrons will only be ejected. That well explains the concept of photoelectric effect. In photoelectric effect, in photoelectric effect, Albert Einstein has a great contribution. Till 1905, everyone thought that light is just a wave. But after the discovery of Albert Einstein in the year 1905, that really explains through the concept of photoelectric effect through photons, that is the tiny particles of light. आप सभी ने देखा है हम होली में बलून से खेलते हैं, तो जैसे ही हम बलून को किसी पे मारते हैं तो उसके अंदर का पानी स्प्लिट हो जाता है। उसी तरह लाइट भी एक बलून के फॉर्म में स्टोर्ड है जिसको फोटॉन्स कहा जाता है, और जैसे ही वो मेटल प्लेट यानी सीजियम या सोडियम पे पड़ती है, सीजियम या सोडियम प्लेट पे पड़ती है, तो वो इलेक्ट्रॉन्स के फॉर्म में एमिट हो जाती है उसकी एनर्जी, और बाकी की एनर्जी काइनेटिक एनर्जी के फॉर्म में कन्वर्ट हो जाती है। फोटो इलेक्ट्रिक इफेक्ट क्वांटम मैकेनिक्स का बहुत इंपॉर्टेंट इफेक्ट है जो लाइट कैमरा सेंसर्स और सोलर पैनल में यूज किया जाता है। सो हैव अ ग्रेट डे एंड थैंक यू फॉर लिसनिंग द प्रेजेंटेशन।
From Central Public Senior Secondary School, going to speak about an interesting concept of physics called the photoelectric effect. The photoelectric effect is a phenomenon in which electrons are emitted from the metal surface when light falls on it. But this does not happen with all lights. Only light of certain minimum frequency called threshold frequency can remove electrons from the metal. When light hits the metal, it behaves like a tiny packet of energy called photons. These photons transfer the energy to the electrons. If the energy is enough, the electrons are ejected immediately. The formula of photoelectric effect is E means energy is equals to V plus kinetic energy. One important point is that increasing the brightness of light increases the number of electrons, but increasing the frequency increases the kinetic energy of electrons. This effect was explained by Albert Einstein, and for this discovery he received the Nobel Prize in Physics in 1921. The photoelectric effect is very useful in our daily life. It is used in solar cells, automatic street lights, light sensors, and camera sensors. Thus, photoelectric effect proves that light shows particle nature and plays an important role in modern technology.
What a semiconductor is a material with electrical conductivity between a conductor like metal and insulator like rubber whose ability to conduct current. Difference between conductor and insulator. Conductor always electric current to flow easily, has a large number of free electrons, low electrical resistance used for making electric wires. Examples: copper, aluminium, silver, iron. Insulator does not allow current to flow easily, has very few or no free electrons, high electric resistance used for converting electricity, covering electric wires. Example: rubber, plastic, glass, wood. Types of semiconductor. Pure materials like Si and Ge. Importance of semiconductors. Control and regulate the flow of electric current. Used in diodes, transistors, and integrated circuits. List of semiconductor devices: diode, transistor, LED, ICs, MOSFETs, and solar cells.
LED, light emission and diode. What is LED? LED is a light emission diode. It is a semiconductor device. Construction of LED. Made of P-type and N-type semiconductor. Junction of formed between P and N regions. Working of LED. LED works in front phase conduction. Uh, Electrons recombine with hole at the junction. Advantages of LED: low power consumption, long lifespan, small size and lightweight, eco-friendly and fast switching. Thank you.
समय की सीमा में बंधे हुए हैं, इसलिए सब समय का ध्यान रखें कृपया। मैं कोड नंबर 217 को इनवाइट करती हूँ।
I study in class 9. Today's my topic is qubits and quantum computer. टेक्नोलॉजी की दुनिया में तेजी से विस्तार हो रहा है। अब इंसानों की जगह मशीन्स ले रही है। एक समय ऐसा भी था, कंप्यूटर के विकास में तकनीकी क्षेत्र में क्रांतिकारियों पर बदलाव था, पर अब ऐसा नहीं है। आर्टिफिशियल इंटेलिजेंस एआई से लेकर हम हथियार बनाने तक कंप्यूटर का ही उपयोग कर रहे हैं। आज कोई भी क्षेत्र हो, चाहे वह शिक्षा का क्षेत्र हो या स्पेस साइंस का, हम उसमें भी कंप्यूटर का ही उपयोग कर रहे हैं। कंप्यूटर जब से बना है तब उसका साइज छोटा हो जा रहा है, पर उसमें काम करने की क्षमता बढ़ रही है। तो आपने आपके मोबाइल में एक चिप देखी होगी, वही चिप 8 से 10 साल पहले 1 जीबी की मिलती थी, पर अभी वह 1 टीबी की मिल रही है। इससे आप अंदाजा लगा सकते हैं कि टेक्नोलॉजी कितनी तेजी से बढ़ रही है। प्रकृति में समझ एक अशोक चक्र क्वांटम कंप्यूटर को कहा जा रहा है, जो क्वांटम कंप्यूटर है, जो आने वाले फ्यूचर का कंप्यूटर ऐसा भी कहा जा रहा है। आने वाला क्वांटम कंप्यूटर आने ऐसा भी कहा जा रहा है, जो क्वांटम में आने वाले फ्यूचर का एक कंप्यूटर है, जो अपने घरों में होने वाले कार्यों पर राज करेगा। और क्वांटम कंप्यूटर एक बहुत ही पावरफुल कंप्यूटर है, जो क्वांटम फिजिक्स पर काम करता है। जो एक सामान्य कंप्यूटर 0 और 1 बीट का उपयोग करता है, वही क्वांटम कंप्यूटर क्यूबिट का उपयोग करता है। क्यूबिट जैसे एक साथ 0 और 1 दोनों हो सकते हैं, इसे सुपरपोजिशन कहते हैं। इसमें एक और विशेषता होती है एंट्रोपी में, जिसमें क्यूबॉइड आपस में जुड़े होते हैं। इसी विशेषता के कारण क्वांटम कंप्यूटर बहुत ही पावरफुल है और यह आसानी से किसी भी चीज को सॉल्यूशन कर सकता है, जैसे कि साइंटिफिक रिसर्च, फूड प्रिडिक्शन, मेडिसिन एंड ड्रग डिस्कवरी, कोड ब्रेकिंग एंड अदर एक्सेट्रा। थैंक यू।